Okay, today I had you exploring the tiles, so I wanted to talk to you a little bit about them. There were 6 different tiles. The first one is this unit tile. We call it a unit tile because if I actually take a ruler and I measure the length of this side, it would be a centimeter, and the length of this side would be a centimeter. And all of the tiles are named the way they are because of the area of them. So they're either squares or rectangles. We're going to notice that some fit together and some don't. This is called the unit tile. It's named the 1 unit, or you could name it the 1 tile because 1 times 1 is 1, and it's 1 centimeter by 1 centimeter. The couple that we're going to work with a lot is this tile. Now, if you notice, it's the royal blue, and this side does match up with this. But if I tried to take these tiles and put them alongside, it would come close, but it wouldn't measure it. This length is actually, we're going to call it X. And it's called non-commensurable because it's just a random length. And the reason we made it a random length is so that we can use it as a variable. So this is our X tile because it's 1. That's the length of this side. And X is the length of this side. And 1 times X is X. The tile that goes with this is the other blue tile. Now this is the square. And if you notice, these sides line up. So that means that this length is X. And this, because it's a square, all the sides are the same. So if I were to label this, this would be X and X. And to find the area, if this were 5 and a 5, to find the area, I would take 5 times 5, which would be 5 squared, or 25. If it's X, it's going to be X times X, which is X squared. So this is named the X squared tile. The next ones we're going to look at are the purple ones. So if you notice, the purple one, if on the edge again, that has a length of 1. These are also, if I went down with these, I would not get an exact measure. These are also non-commensurable, and the reason that they are is because sometimes we're going to be dealing with 2 variables. So we wanted something that represents the second variable. So this doesn't mean that y would always represent a number that's longer. It's just we wanted it to be different. So this length is going to be called y, and this is 1. So this is called the Y tile. And if you line up this sides, this is going to be a square that's Y by Y. So Y times Y is Y squared. This is our Y squared tile. And then we have one more this year, and it's our green tile. And so if you were to play around, you would notice that this length is the same as my Y tile, and this length is the same as my X tile. So to find the area of this particular tile, I would take X times Y. So this is my XY tile. I will put this on a form, and it'll be in our classroom as a resource. And then tomorrow we're going to, well, actually today, because I'm going to post this tomorrow, we're going to practice simplifying. If I put a whole pile of these down, practice simplifying. How would I describe that pile of tiles? For instance, this one would be described as 1y plus, then I have a y squared, so 1y squared, plus, then I have an x squared, so plus 1x squared, and then I have an x, so plus 1x, plus 1, that's my unit tile, plus 1xy. If I threw other things in, if I threw a couple more of these in, like so, I would name this tile, I would group them together and put my x's together, my x squared, my xy, and I would name this 2xy plus 2y squared plus a y plus a 1 plus 2x's plus 1x squared. Okay, we'll practice some more of that in our next form.